Alright, we pick up where we left off, which is talking about the first alternative, maybe, to fossil fuels. What is it? Well, it's nuclear energy. Why are we starting with nuclear? Why aren't we going straight to renewables? Well, we're going to talk about that, but the main reason is that people see nuclear energy as being a medium-term solution, not a short-term, not a long-term. They kind of see nuclear energy being somewhere in the middle of that. But like with everything else we do, we got to go back to the beginning, and we got to figure out how we got to nuclear energy. So what we can do is, in this case, a lot of nuclear energy is going to start with military testing back near World War II. So we go to the middle of New Mexico, which is where we did a lot of our testing. And we go to the middle of the New Mexican desert. And what we do is, like we talked about in the introduction unit, we have to set a control group, right? We have to set something to compare it to. Well, we go and do what we call the 100-ton test. The US military goes out way, way, way in the middle, far away from nowhere, New Mexico. And what they do is they set off TNT laced with radioactive material, basically. And the point of this was to calibrate all the instruments that they were going to use when they tested all these bombs. Like if you're going to, drop bombs from the sky atmospherically, and if you're going to test from underground with them buried, you got to know what you're comparing to. So what they did is that they set it up and then they started working on it. But before that, before we can get there, we need to learn what the basics of an atom are. Now, you've probably talked about these in your previous classes, and that's great. You're going to review a lot here, but you're also going to learn some new stuff, so pay attention. Before we go anywhere else, we need to know the very, very basics. So, in the atom, in the smallest part, what we have is 3 subatomic particles. We have a proton. A proton is positive. We have a neutron. A neutron has no charge. It's not zero, it's no charge. And we have an electron. And electrons are negatively charged. Now, we can look at that, and you've probably talked about this, and this is like, yeah, I know. We talked about this before. Why is he telling us? Because you got to understand it for the next couple of things I'm going to explain to you. Remember that protons and neutrons, the positive and the no charges, live in the nucleus. They live in the middle. And the electrons go around the outside of this. Now, what you've been taught before is that they kind of go around in these circular things and they have energy levels and all that. Not totally true. That's called the Bohr model. It's not exactly right. It's good to learn, but it's not exactly right. We'll talk about that later, and you'll definitely talk about it when you get to chemistry. Why do we need to know that? Well, we need to know that they like to be electrically neutral, meaning they like to have 6 protons and 6 electrons in the case of carbon. By doing that, they also have 6 neutrons, so everything is even. All the numbers make 0. But, like with everything, not everything is perfect all the time. Sometimes these electrons are added or removed, and you might have remembered talking about that. That's kind of how bonding happens, right? Well, when you remove an electron, it becomes positive. Or if you gain an electron, it becomes negative. When a nucleus, or when an atom, I should say, gains this electrical charge, whether it's positive or whether it's negative, it's called an ion. Now, you've probably never heard ion before, or if you had, you didn't know what it was talking about. Do not confuse an ion with an isotope. An isotope is when we add more neutrons than what is normal. So in the case of carbon, again, let's stick with that since we've been talking about it all of the energy sources unit so far. It's had 6 protons, 6 neutrons, and 6 electrons, right? Well, sometimes we have 7 neutrons. That makes carbon 13. Its number, it comes from 6 plus 6 is 12. In this case, it's 6 plus 7 is 13. Well, sometimes we can add even more to that, and it gets to be carbon 14. How does that happen? Well, we have 6 protons. You can't change the number of protons. If you change the number of protons, you have a different a different element, But you can have an isotope, which has these different number of neutrons. You get enough there, or you put them in the right situations, they become unstable. As they try to break down and go back to what they want to be normal, they want to be, neutral, radiation is released. And radiation is going to be the basis for all of the rest of the nuclear energy notes. So, what we talked about in astronomy, and hopefully you remember that, is fission and fusion. Well, we're going to talk about fission first. Fission, remember, is when we split these atoms apart. When we take a nucleus, the first one we used was uranium-235, and uranium-235 was used because, relatively speaking, it's pretty large, and it's easy to hit with a neutron. So what does that mean? Why do we want to hit it with a neutron? Well, when you hit one of these nuclei of the uranium-235, then it splits into two. Well, we now have two different particles that can then go and hit other nuclei, which hit other nuclei. You get the idea. It creates a chain reaction. You have a big enough chain reaction, and you have just an enormous amount of energy that is released. Now, you can use this constructively or you can use this destructively, and we're going to talk about the differences, and we're going to talk about how that happens and why that happens and which one we want to use when. But when you have this chain reaction, just energy is created. You got to learn how to stop it, but we don't care about that right now. So we detonate this first nuclear bomb in the test site called Trinity. You can still go out to New Mexico today and go to the Trinity test site, and it's still there. There's a monument dedicated to the first nuclear atmospheric test. And you can still see trinitite, which is this green and whitish looking glass. Well, where did it come from? It's the middle of the desert. Why is glass there? So much heat and light is emitted from a nuclear weapon when it is detonated that it literally takes the sand and fuses it together into this glass material. And it is the only place that you can find this in the world. It is the only place where it exists because it happened in that exact spot when they went to test these nuclear weapons. So, we all know that we used nuclear weapons, and whether you like it or whether you don't, or whether you think it's cool or whether you think it's not cool, we need to talk about a little bit of the backstory. We being the United States, used 2 nuclear weapons in World War II. We're the only country that has ever used nuclear weapons, and we used them both on Japan. Now, yes, it did end World War II, and yes, it is good that the war was over, but think about, and I'm not trying to take sides here, and I don't want to get political, and I just want you to stop and think about this. Like, is this stuff interesting? Yeah, it's definitely interesting. Is science interesting? I think it is. That's why I teach it, of course. But think about all the people that lost their lives that weren't even part of the fighting or the military, and think about what would happen if we used one today. Well, those bombs were 15 to 21,000 kilotons, so 1,000 tons. Today we measure ours in megatons, so million tons. Think about what would happen if we actually used one. I hope we never see that, and I hope none of you want to ever see it used. And while it is cool to learn about, and I think it's cool to learn about, the thought I want to leave you on with this video is, if science is going to be used, then science is a tool. Science is not good, science is not bad. And if anyone tells you that it's inherently good or if it's inherently bad, then they're misunderstanding what science is. It's simply a tool that we use to gain knowledge about the world around us. You can use it for good, to cure diseases or something like that. You can use it for bad, hurting or killing people. What you do with it is what you do with it. But just remember that as we go through this, and the next thing we're going to talk about is the atomic testing after World War II, and a lot of incidents has happened, just remember that science isn't one or the other. It's what we do with it. Now, I know that's kind of a down note to end this video on, but just keep that in mind for me. Thanks.